Okay, so now we're going to do the opposite of expanding logarithm expressions, and that's condensing. We're going to use the same three basic properties. So if we review those, the first one is our power rule. So if we have log base b of m plus log base b of n, we can rewrite that as log base b of the quantity of m times n. The quotient rule, so log base b of m minus log base b of n, says that we can rewrite that as log base b of the quotient of m divided by n. And then lastly, we have our power rule, so p times log base b of m equals log base b of m to the p power. So really when we're condensing our logarithms, we're going to always work from the bottom to the top. So we're going to move our coefficients to be our exponents first, and then we'll do our addition and subtraction into multiplication or division. So if we just look at those first two properties, rewrite a single logarithm, so log base 4 of 2 plus log base 4 of 32. We can't simplify either of these expressions, but if we condense them into one log base 4 of 2 times 32, we get log base 4 of 64. And 4 to what power is 64? And that would be 3. So we can rewrite that single logarithm and then also simplify it to get one number. Okay, looking at b, we have log of 4x minus 3 minus log of x. So we're going to condense that into one logarithm. And since we're subtracting, we're going to divide. So 4x minus 3 divided by x. And we're only dividing these two parts that have logs. We're not dividing this 4x minus 3. Okay. So condensing logarithms is going to help us with what we're going to do in 4.4 with solving logarithmic equations. Okay, so if we combine all three of our rules now, we have 1/2 log of x plus 4 log of x minus 1. We're going to start off with moving our exponents, our coefficients to our exponents. So we can rewrite this as log of x to the 1/2 power plus log of x minus 1 to the 4th power. And then since we're adding, we can condense further to one single log of x to the 1/2 times x minus 1 to the 4th power. Okay, looking at b, 3 times the natural log of x plus 7 minus the natural log of x. We're going to take that 3 and move it to the cubed power. So we have the natural log of x plus 7 cubed minus the natural log of x. Since we're subtracting our two logarithms, we're going to rewrite that as the natural log of x plus 7 cubed divided by x. Okay, and looking at c, we have 4 log base b of x minus 2 log base b of 6 minus 1/2 log base b of y. So start with moving all of your coefficients. And we're just going to move the numbers, not the signs. So this becomes log base b of x to the 4th power minus log base b of 6 to the 2nd power minus log base b of y to the 1/2 power. So remember we said that anything in our numerator is going to be positive or addition, and anything in our denominator is going to be negative or subtraction. So if we use that property, we can condense all three of these at the same time. So this equals log base b. Our numerator is going to be x to the 4th, since it's positive, And then we have two negatives here, so we're going to have 6 squared and y to the 1/2, all in the denominator. And then we can simplify that further. Log base b of x to the 4th over 36 y to the 1/2 power. And that is your simplified condensed logarithm. Okay, so the last property we're going to talk about is the change of base property. So this allows us to be able to plug any logarithm into a calculator. So far we've talked about how to plug in logarithm of base 10, which is just our common logarithm, so like log of 6, or our natural logarithm, so ln of 6. Okay. So some calculators allow you to type in this log base b, okay, but not all of them will. So what we're going to use is this change of base property to allow us to plug any logarithm in. So we're going to use log base b of m equals log of m divided by log of b, or log base b of m equals the natural log of m divided by the natural log of b. I don't care which one you use unless it says in the directions, and that's going to be one thing on your homework and your quiz you need to be careful about, is it will tell you to use a common logarithm or a natural logarithm. So remember, the common is our log and the natural is the ln. Okay, so easiest way to remember which one goes in the numerator and which one goes in the denominator is the base b equals the bottom. Okay, so we look at this first example. Log base 5 of 140. We can rewrite that. I'm going to move the log base 5 goes to the bottom, so log of 5. And then the numerator is going to be log of 140. And then if you plug that in your calculator, make sure you're going to have log, and it's going to open your parentheses of 140. Make sure you close that before you click on your division sign. And when you plug that in, you should get 3.07 when we round to the nearest hundredth. And then looking at b, log base 7 of 2,506. If we look at our denominator first, the bottom would be log of 7. And our numerator would be log of 2,506. Remember to close the parenthesis after the 2,506. And when you plug that into your calculator, you should get approximately 4.02.